Hello everyone, welcome back to the Gate Engineering online learning classes. In this video, we will talk about subtractions using 1's complement. This is the subtraction in the binary number system. With the help of 1's complement, we will see the subtraction of binary numbers. In the last video, we have already talked about subtraction using 2's complement. Here, we'll discuss two cases. Case 1 if m is greater than n and case 2 if m is less than n for the subtraction of n from m. So we will perform the operation m minus n. One case m greater than n, here result will be positive. Second case m less than n, where result will be negative. And in this video, we will discuss the subtraction using 1's complement. So we have given two number, one is m, which is 101111 in binary. We have given another number which is n in the binary 1001110. So step one is m plus 1's complement of n. So this is quite similar to the subtraction using 2's complement, in which we perform the operation m plus 2's complement of n. But here subtraction using 1's complement, we will do m plus 1's complement of n. And 1's complement of n is nothing but just toggling the bits. So 1's complement of given number 100110 is 011001. So now we perform the addition m with n. So m is 101111 plus 011001. Now we'll add 1 plus 1 is 0, sum is 0, carry is 1. 1 plus 1, sum is 0, carry is again 1. 1 plus 1 again, sum 0, carry is 1. 1 plus 1 plus 1, sum is 1, carry is 1. 1 plus 1, sum is 0, carry is 1. 1 plus 1 is sum 0, carry is 1. So here you can observe one carry is propagated here. We can see one extra bit is added in the sum, which is indicating that overall carry is generated. So always remember the case if m greater than n, carry will always propagate in the sum when m plus 1's complement of n or m plus 2's complement of n. So always carry will propagate here, always carry will generate here if m greater than n. So in this case, in the case of m plus n, in the case of 1's complement, in the case of subtraction using 1's complement, we add the carry. Add carry with sum. Add carry with sum. So our sum addition was 100100. So m plus 1's complement of n is 100100. So what we'll do here? This is the carry that will add with this result. And we'll get final sum which is 001110001. So this is the result in binary. So what numbers we had? We had number 101111 101111 minus 100110. With the help of subtractions using 1's complement, we got result 001001. You can verify this result is correct. And you can also verify with the help of decimal conversion. 101111 in decimal is 47. You can easily calculate. I have already converted this number in the decimal in the last video, 47, and 100110 is it's 32 plus 4 plus 2, that is 38. If we subtract 38 from 47, you will get 9. So this is the result which is correct. 1001 is nothing but 9. So in this problem, what we have done, we subtracted the number n from m with the help of 1's complement. So By using the ones complement, we add the ones complement of n with m. We get some result. Case is m greater than n. Always carry will generate here. So this carry will be added to the sum and we'll get the final result after adding the carry. And this can be verified with the conversion of the in the decimal also. Now we'll consider the second case when m is less than n. M is less than n means m is less than n. Our result should be negative. Okay. So m is 100. Always this is 4. All of you know. N is 1100000, which is 48. This is also. Okay. So now we'll see how to perform the operation. This 4 is the decimal. This number is in the binary and 48 is in the decimal. Okay, so we need to perform the operation m minus n. So step 1, m plus 1's complement of n. So m is 100 plus 1's complement of n will be toggling the bits of n 0 0 1 1 1 1. So we'll write 100 and we can add extra 30 in the left side to make an equal number of bits as n, and we'll add this number with 0 0 1 1 1 1. So this is the m, this is the 1's complement of n. We'll add both and our result is 1 1. 1 plus 1 is 0, carry is 1 here, 1 plus 1 is 0, carry is 1, and we're getting this result 0 1 0 0 1 1. 0 1 0 0 1 1 is our result of m plus 1's complement of n, and here we can say that there is no carry. No carry, it means our input was m less than n. Our numbers was m less than n and we are performing operation m minus n. So we'll take the ones complement here in the second step. Take ones complement of sum. Take ones complement of sum with the negative sign in front. It is quite similar to the subtraction using 2's complement. In this using 2's complement, we perform the operation m plus 2's complement of n. If m is less than n, it means without carry case, we take the 2's complement of the sum. But here we are using the 1's complement, so we are taking the 1's complement of sum and we'll apply the negative sign. So 1's complement of this number will be 1's complement of 0 1 0 0 1 1 is 1 0 1 1 0 0. And we need to apply the result. So result is minus 101100 in pi. So this is the result that we have, and we can verify our results that it should be minus 44 because we are subtracting 48 from 4. That should be minus 44. So if you convert this number, it should be equivalent to 44, and our result is negative. So 101100, which is you can write it as 32, 16, 8, 4, 2, 1. These are the weights of the weight 1, 0, 1, 1, 0, 0. 32 plus 8 is 40, 40 plus 4 is 44. So this is the 44 in decimal, and our this result was negative. So this number is minus 44, which is correct, which is absolutely correct because 44, 48 subtraction from 4. So 4 minus 48 is minus 44. So our final result is minus 44 that we got as in the binary with the help of 1's complement. And same problem we have already solved with the help of 2's complement in the last video. I hope you get the clarity about the subtractions by using binary number system with the help of complements in last two videos. In these last two videos, thank you very much for watching this video. Subscribe the channel for more such kind of the video on the digital electronics or some other topic. Uh, Thank you very much once.